Okay, I have made a lot of videos about shimming, and for some reason people have a hard time understanding bevel to pinion. So I'm going to make a short video, lay out everything on the table, and try to make people understand. We're going to work here with, let's see, I need a small screwdriver. I need this one. And what we're going to do, get out the watt meter, kind of explain things here. First thing, we've got a demo gearbox here from one of my other videos, and we can see that nothing is shimmed too tight and no binding. So what you hear is teeth to teeth, between teeth to teeth movement, and down here we can see the bevel to pinion. Okay, now what is right here being shown, it's hard to see, but there is basically the tiniest amount of space between the bevel's teeth and the pinion's teeth. So kind of imagine like hair or a piece of paper that just can go right between there. That's how much space there is. These lights help out the situation. So we can see here. It's a very bright light. Okay, so right there you can see bevel to pinion is really close. Now how do I know exactly that I have bevel to pinion? There's two things that I actually do here. One is I do a test with teeth to teeth movement, and two, you can see the teeth to teeth movement is really slight, and two, I spin this gear right here. So I actually rotate it and feel the resistance. If it's very resisting, it's very hard to turn, and it's exactly how the motor is going to have to turn that gear. As hard as it is for you to turn it, the motor is going to have to turn it. Because the pinion is bounded here, almost bounded, I mean it's so close, it's going to be the same torque for this motor to turn as you are turning for this bevel gear. The same. So it's measuring, you're measuring the resistance by doing this. Now to imagine this and make it a little bit easier for you, we're going to take out a motor here. This is the aim top motor, and we're going to take a bevel gear here, and I think this is a Siege Tech 14-1 bevel gear right here. So there should be 30 teeth down here in this region. Now with this, they're simply not going to mesh together, and what that means is there's little markings and so forth in the teeth, and sometimes these are a little wider, but the noise is what I disregard. What you're going to follow is mechanical. So to show, this gear needs to be parallel inside the gearbox. Parallel means that it is basically flat, not it's supposed to be straight, so it's not bent. So it's going to be like this in your gearbox, depending on how you're holding your gearbox. If you're holding your gearbox like this, it's going to be parallel like this. Okay? There should be no amount of pressure or anything pushing this gear out of alignment, because it is not designed that way. Now, when I say that, that simply means it is not designed that way. Here's a Siege Tech spur gear, and if I put this in the teeth here, imagine me bounding this up. So if I was to put pressure here, is this supposed to spin like that? No. Same goes the other way, but this does not happen this way. When you put the pinion in, all it does is it pushes the bevel up like this. Sometimes it's a little bit lifting, but it usually pushes it up like that. So if I'm looking to you, this is what it would look like if I was to push the pinion right here up. Okay. Now, what people do not understand is if it's in the gearbox like that and you close it, it won't look like it's pressed up. Okay, it's going to look parallel, but when you shoot it, not only is it going to have that mechanical resistance, it's going to show it on your amperage on your watt meter, but you can feel it. If you were to use the screwdriver test that I was showing earlier, you could feel this gear could not turn very well because it's bounded by this gear, this pinion gear. It's bounded, it's held tight, it's being pressurized. So the same thing goes on, the same method applies when you shim your gears. Why would you take this and apply pressure into the teeth here? I mean, why would you press it down into? So if you were to shim this up and this down, and you try to have this rotate, it's the same damn thing. Okay, I've been explaining this for a long time and people still don't understand. If it is not parallel, when you close your gearbox, all it's going to do is it's not going to look like it. It's going to look like it's parallel, but it's going to be so much pressured. And when you go to shoot, it's going to have mechanical resistance. So, to see with the level tests that I use, basically want to take your gearbox, open up the screws here, and just hold it like this best you can. And your gear should look parallel. Once you put the pistol grip on and you put the motor in and you adjust, it will go in and slightly press the bevel gear up the closer and closer you get, especially if you don't have any shims on the bottom of your bevel gear here, because it will hit right into it. So to show right here, here's your bevel gear, and if I had this low, it will hit right into it. See that? See, it hits right into it. So if it's too low, it's going to push it more. If it's high enough, you can get right underneath it. And that's what you want to do. You want to be right underneath it. Now, that doesn't mean you're going to be able to with every single gearbox, gear set, and pinion gear, and pistol grip, and version gearbox you have is not going to be like that. Sometimes you'll get a case where the parallel is about like this. Okay? You can see there's some teeth there showing. Alright? Now, if you were just pushed in, you'd have pressure. You do not want to do that. You do not want to do that. The idea is to get enough of this teeth here to be able to rotate this bevel gear, but also keep the bevel gear flat, parallel, straight in the mech box. Okay? That should make 100% sense to anyone that understands mechanically how gears rotate. You do not want to add extra resistance. You want it to be as simple as possible to turn and just no resistance. Now, I don't know how else to explain this. I mean, I get agitated when people don't understand, and I clearly show. In a parallel test, it's hard to hold the gearbox. Let's say this is your gearbox. It's hard to hold it straight, put your motor and grip and everything on there, and just see how parallel it is. The way you want to do it is put your gearbox together and see where your pinion gear is. So for instance, you can see here, this is closed, and you can see where it is, and you can do your test here. Now if you can't reach this, you can do your test from above, from inside the gearbox, and you just move the bevel gear and see how much movement it has. Now the tighter it gets, the less movement you have. If you have a tiny bit of movement, it's not bound. But at the same time, you want to make sure that it can grab enough of the teeth. You can see here, it's practically 100% right there. See how it's almost 100% grabbing the teeth. There is no magical, I don't know why people think this, there's no magic for pressing the pinion onto the bevel like this, and there's definitely no magic for leaving extra space for this bevel. You can make this bevel less than 0.1 millimeter of shimming space. So that means that if you have less than 0.1 millimeter, which you're supposed to have, that's the best shim job you can get, unless you have a smaller number than that. But you cannot have anything that's equal to 0 or less than that. So let's say you have 0.05 millimeters. Okay, that's going to work perfectly. There's no reason why it will not bound up. Now if you start taking out shims and you let it move up and down, that is improper shimming. This is supposed to stay where it is and spin where it is. Does that make sense? Yes. You don't want this moving up and down at all. You just want it to stay where it is. It's like you're trying to make it controlled in the space it's supposed to be at. It just stays there. But for some reason, people think that if you take this motor with a pinion and you shove it pushing pressure against the bevel, it helps it spin better and it gives a better noise. Of course it's going to give a little bit of a better noise. It can't spin very well and it's pressured into here. Okay? This mechanically is going to show more amperage because it has a much harder time to turn. It is proven fact. This will tell you, my test will tell you, and you will see that this is not level, not flat, not parallel in the gearbox. So if you still disagree with all of this, then you do what you're doing and I'll keep doing what I'm doing. Okay? This is less likely to fail. Alright? Why? Because it's not moving like crazy and it doesn't have any pressure pressing against it and it's not at an angle. Does this make perfect sense? Yes, it does. Now, as far as how far back to move or how far up to shim this is kind of like this to explain. So if you have this parallel and you get this underneath here, and if you can get the whole thing underneath there and it's still parallel, then that means you're good to go. But you have to test if this is too low. So for instance, it could look like this in your gearbox. Let's put this here. You've got the motor here. Okay, that's terrible, excuse me. You want to have it just a little bit, where it's basically like a hairline of space. Alright? Any more force, if I was to push this up a little bit, let's say adjust it, push it a little bit, see how it lost its parallel? So you want to drop just a little bit, and that should be parallel. And this should be stable, and it should not move. And as this rotates, this will rotate just like that and spin the proper way. Okay? Now, one more thing to explain. In my test, the reason why I spin it, why I use a flathead, is because if you look at this gear and you look at the pinion, the deep valley right here between this and this could be at a separate location, so it won't be straight in view. So I want to kind of show this. So let's say this is at the bottom right here, and if I was measuring this, that would be straight. But let's say I turn the gear a little bit, then the bottom is the 2 here, because the bottom, the bottom is going to be this tooth here, which is going to be too high. So what's going to happen, to best explain this, is you put this motor in right here, and when you go to check it, at some points it will seem like there's a tiny bit of slack, but as you turn it, if you can get to that exact point, you'll start to feel the slack is less or more. So this is why I turn it, because these teeth right here, they may be a little bit of a different location during the test. So if your teeth your teeth are right here, so if you're checking when your pinion is right here on this tooth, then when you go to check it, that would be the best way to check, because that will tell you if the tooth is actually cradling and pressing down into the gear. If you go to check it when it's a little bit this way and the gear is between here and here with 2 teeth, then you can't tell until you start to rotate. Okay, it kind of sounds like, what the heck are you talking about? But it really is true, because as this spins, if it is just a tad bit too close, it will press down into the gear. And even though this will work very well, it'll work fine, this thing will tell me that, hey, there's a little bit of pressure, you're a tad bit too close. So you have to be a tad bit further away. Okay? That's how I do my beveled pinion. That's how it should be correctly done anyways. You don't want to put pressure on this thing, you want to keep it straight. So I think this beveled pinion is pretty much explained. If you don't get it from this point, you'll never get it. And I as sure as heck wouldn't let anybody tech my gun if they do not understand something that simple. Even though it's a little bit complex, they should understand it mechanically. I don't think there's much more for me to say here. I think I pretty much gave that out. If you want to check other videos for shimming, I'm going to go ahead and put them on the right here and check those out. The difference in pinions to bevels will give a different noise depending on the mesh. We kind of talked about this before. This one is definitely different than this. You can see one will be bigger than the other. Let me see here. I want to get this is a garter one, I think, and you can see that this one's fatter than this one. So it's definitely going to be a little bit different on the noise as it rotates. I'm looking for I guess this is the one I'm looking for. And here's the one I'm looking for. Here's a Siege Tech pinion gear. And you can see it's a tiny bit smaller than the aim top. And it is actually more parallel, or excuse me, more of a 45-degree angle of each tooth, like this. The aim top kind of shapes down like that, but then they cut it. You can see right here, there's little cuts in the teeth. They purposely do that. They purposely cut this last section off. I'm not sure why. But if I actually take out a name top gear and show it to you, it does not even mesh very well to this pinion gear, which I'm not sure why. But if I take out a Siege Tech pinion and mesh it to the Siege Tech bevel, it meshes very well. So I will catch you guys later. Again, check out those videos. I'll do another quick videos, but I just kind of lay this out on the table because I'm not sick of the questions. I'm sick of trying to explain and people do not understand. That's what I'm getting at, and they keep putting their foot down like I'm totally wrong, but this is totally showing you that there's no way I can be wrong. I'll catch you guys later. Hit you with a fist.